So one tricky piece about the law of signs is what's called the ambiguous case. The ambiguous case is where you have side-side angle. So let's, for example, think about some triangle. If you have a triangle, and we'll name the vertices of this triangle A, B, C, which makes this side A, this side B, and this side C, if I give you, let's say B is equal to 12, A is equal to 13, and B is equal to 89 degrees. Here we can see that I'm given in order side, side, angle. Now this is not something we would use to show congruency with triangles in geometry or really do anything, but this is called the ambiguous case because it could give us 0 triangles, 1 triangle, or 2 triangles. Now, there's a lot of different rules to use with the ambiguous case, but I'm going to guide you through 3 examples here where we have an example of when we have 0 triangles, 1 triangle, and then 2 triangles. And we're going to ignore all those rules and basically assume that each problem is going to give us 2 triangles. And by assuming that, as we go through the problem, we will eliminate the other choices automatically. So for example, we're given this problem. Here, again, it's going to be side-side angle. So if I make a little table of values here, I'll say, all right, angle A is 60 degrees, side A is 8, and side C is 19. I can solve this for angle or I can solve this using the law of sines, and I'm first going to go for angle C. I'm not going to go for angle B or side B because I don't have either of those values, so I can't find the other. So I do law of sines, and I say that sine of A over A is equal to sine of C over C. And again, when I plug in my values here, I get sine of 60 over 8 is equal to sine of C over 19. So if I multiply both sides by 19, I get 19 over sine of 60 over 8 is equal to sine of C, but I can get C by itself if I take the inverse sine of both sides. So I get this. So if I plug this into my calculator here, so I say, all right, well, let's see. Well, first off, I'm going to find 19 sine, horrible memory, 19 sine of 60 divided by 8. So if I get that, I get this. Now, hopefully, this should set off a red flag for most of you because we can't take the inverse sine of something larger than 1 or smaller than -1. Because if you think about a unit circle, the radius is 1. So the largest the sine value can ever be is 1. And in fact, if I take the inverse sine of this, I'm going to get an error. And again, reason is this is undefined. So this gives us an error, so that means that there is no triangle, so there is no solution. This is the case where the ambiguous case gives us 0 triangles that will work. And if you think about what that would look like, you know, A is 60 degrees, so, oh, I don't know, maybe that's like this. So side A over here is going to be 8. And if we say that this is angle C, side C is going to be 19. That's just not going to work. I hope that's you can see that with this picture, unless we make this a quadrilateral. Because here, this side right here, 8, it's like a little T-Rex arm. It's too short based off of this angle. But again, if you can't realize that, it's all right. The math shows us that by having this as an error, we see that's no solution. The ambiguous case gives us 0 triangles. So here's the next problem, and again, we're going to start off by assuming that there are 2 triangles. So I go through this. If I need to graph these points just to get a picture to see that this is side-side angle, I can do that. But here I won't. I'll just say it's side-side angle and have you believe me. So it's side-side angle, so it's an ambiguous case, so I set off looking for angle B. So I do sine of C over C equals sine of B over B. And I say that sine of 68 over 27 equals sine of B over 22. Again, if I multiply both sides by 22, I get 22 sine of 68 over 27 equals the sine of B. And if I take the inverse sine of both sides, that cancels out. So if I put this into my calculator, so I could do inverse sine of 22 times the sine of 68 divided by 27. And so I put all that in my calculator, and it tells me, excuse me, it tells me that this angle is, let's just say that's 49. So B equals 49 degrees. That works. It's an answer. Here's where the ambiguous case comes into play. We're going to assume that it's two triangles. And so I was originally given that C is 68 degrees, side C is 27, and side B is 22. What we need to focus on are these angles B. The original angle B was 49. This angle B will be what's called the coterminal angle, and they are going to be supplementary. So that means that these two angle B's, these second angles, should add up to 180. So if this angle is 49, this angle B in my second triangle is going to be 131 degrees. And that's my second triangle. If it works out, great, it works out. I have two triangles. I make this into two separate problems. However, with this, we can see that these two angles just in themselves equal 199 degrees. A triangle only has 180 degrees between the three angles. So already these two are larger than that. So that means that this second triangle actually is not possible. I only have one triangle. And so I solve this first triangle just like I would for the other ones. So if I have 68 and 49, that's going to be 117. And if I subtract that from 180 degrees, I'm left with angle A, which is 63. To find side A, I again use law of sines. So I say A over sine of A equals B over sine of B, or I could use C again. So I do A over sine of 63 equals 22 over sine of 49. So it means that A is going to be 22 times the sine of 63 over the sine of 49. I can get rid of this fraction here by multiplying both sides by sine of 63. So if I do that in my calculator and I say, all right, well, what's 22 sine of 63 divided by sine of 49? Watch out for those parentheses there. I get this, 25.97. If I round that, that's just going to be 26. And so there we go. There was no large process with that. We just assumed that there would be a second triangle here. It turns out that wasn't the case, so it went back to just a normal one triangle law of sines problem. Nothing overly complicated. It can be tricky, though, that you have to remember to find that coterminal angle. But that's really the only instance you would need to do it. And so finally, we have this third example here. And by process of elimination, this must be the one that actually does give us two triangles. So we're going to take a look at that. So I'm going to make, again, my handy little table here. that shows all these values. I'm going to prepare myself and make two tables here because I know that I have a side-side angle type situation that could give me up to two triangles. And so because I have both B's and one A, I'm going to first find what angle A is. So I set up sine of A over A equals sine of B over B. So that means that sine of A over 32 equals sine of 26 over 17. If I multiply both sides by 32, I'm going to have 32 sine 26 over 17. And to get that angle A by itself, I just take the inverse sine, of all of that. So if I take the inverse sine of 32 times the sine of 26 divided by 17, and I can just put that all in my calculator, I get that angle A is 55.6 degrees. And again, if I got an error, I would know it's 0 triangles. I didn't get an error, so I know that there's at least one triangle. So because I have this 55 degrees, or 55.6, I find out what the other angle A could equal. And I do 180 minus 55.6. That gives me 124.4. Now if I add up that 124.4 plus 26, that's going to give me 150.4. That would leave me with 29.6 degrees. That's a full triangle. That works. So now I just have to find out what angle C is. Now in this original triangle, I have 55.6 and 26 degrees, which add up to 81.6. That leaves me with 98.4 degrees. So now I have these two situations here. I have these two problems, and I just solved them individually. So first off, I have C over sine of C, and I can do either one. I could do A over sine of A or B over sine of B. So here I'll do C over sine of 98.4 equals 32 over sine of 55.6. So we say, all right, C is equal to 32 times the sine of 98.4 over sine of 55.6. So there's a lot to be done here, so I'm just going to put that all into my calculator. So I have 32 times the sine of 98.4. And I'm going to divide that by sine of 55.6, close my parentheses, and I get that side C is 38.4. So C is 38.4. Now I could try and look at this other case where I have C over sine of C equals A over sine of A, and I say, all right, well, C over sine of 29.6 is equal to 32 over sine of 124.4. And again, you can see that this A is actually different from the first A. But no worries. I get C is equal to 32 sine of 29.6 over sine of 124.4. That's a 1 in a parentheses there, so I do 32 times sine of 98.4, just like I did before. Oh, sorry, sine of 29.6, different triangle there. 9.6. And I'm going to be dividing this by sine of 124.4. And that gives me 19.2. So that means that this C is 19.2. So if we recap, if we look at the law of sines, we have this ambiguous case where we have side-side angle. We basically go about solving the first angle as we would any other problem. If we get that there's an error, it's not possible, that means there's no solution. There are 0 triangles, and that's okay. However, if we do get an answer, if we do get an angle for that first missing angle, in this case B, what I also need to do is find the coterminal angle, where I take that angle I just found and subtract it from 180 to get the same angle in a different triangle. So here I found 49 degrees. I subtract that from 180 to get 131. That means that same angle B in a different triangle would be 131. However, that 131 plus the other angle I already had, 68, was well above 180 degrees. So that second triangle doesn't work, so I just focus on that original first triangle. Now, if it does work out, and here I found that my first angle was 55.6, and if I subtract that from 180, I get 124.4. That actually does work because I was given 26 degrees. That's less than 180, meaning that in the second triangle, angle C would be 29.6. In the first triangle, that remaining angle would be 98.4. Since both cases, all angles add up to 180 degrees, this is a situation where I have 2 triangles. So the ambiguous case can have 2 triangles, 1 triangle, or 0 triangles.